Hi. Last time in part 1, I have explained the different type of the load applied on a component, and due to the different type of loading, what are the different type of stresses developed in a component. We have also seen it. Basically, there is two type of loading: normal and shear stress. Normal stress again divided into the three types: tensile, compressive, bending. And shear stress is also two types. One is torsional shear stress and other one is the direct shear stress. Direct shear stress, if it is applied perpendicular to the load applied, which is also called the transverse type of the shear stress, applicable in a beam. So we have also seen it in that part 1. If two normal type of stresses applied in a component, then to find out the resultant, we have to just do the algebraic summations according to the sign conventions, that is tensile positive, compressive, negative. If two shear stress applied in a component simultaneously, then to find out resultant, again we have to do algebraic summations with sign conventions. But if one normal and one shear stress applied simultaneously in a component, then to find out resultant, we cannot do the algebraic summations. We have to use the principal stress theory, that is the maximum principal stress, minimum principal stress, or maximum shear stress theory also. Today, I just explained one problem. If that combinations type of that load applied, then how to solve in numerical. But before that, I think in the last portions of the part 1, I had given you some real life example of the combined loading. These are that all example. Out of this, the first 3 figure I had explained it, and I had given you that one as an homework also to think on what are the different type of the stresses produced in case of a figure 4, 5, 6 and 7. So I just give you quickly the answer of this one. I think all of you also think on and getting the correct answer. For the figure 4, we are applying, it is in one cycle paddle, and we are applying the force here. Due to this force is having shear stress, so I think it will be that transverse type of shear stress, tau TV. It will also bend it in this nature due to the load applied here. So there is some sigma B, as well as due to the torque applied on this, some torsional shear stress is also applied in this case. So I think 3 type of that stresses is applied. Just check that final answer. Yes, it is sigma B, tau T and tau TV. Now if you go to the figure number 5, it's an engine carrier in the soft floor. And if we want to find out the shear stress in this surface, we know there is some weight of the engine applied here. Due to this weight, there is some bending moment is applied. So we are getting some bending stresses on it, as well as some compressive stresses is also applied here. So you are getting some normal stress, that is in compressive stresses. In this sections, we are only getting 2 type of the stresses. Figure number 6, it is a signboard. So on this signboard, there is some weight applied here, some wind pressures perpendicular to the signboard. If I want to find out the resultant wind load, that is wind pressure multiplied by the cross-section area of the signboard, then what are the different type of stresses produced in these sections? Due to this W, we are getting compressive stresses here. Due to this W again, some moment applied in this direction, so we are getting bending stresses here. Due to this FB also, we are getting some bending stresses. Then due to this FW, some torque is applied along this axis, so we are getting some torque also. And for FW, there is some shear, transverse type of the shear stress is also applied. So here we can get some transverse shear stress also. So you can see it. There's a total 5 type of the stresses applied. Out of this, the 3 is normal and 2 is the torsional shear stresses. 2 is the torsional shear stress. So how to club it, that we have to check it in some problem when we solve this problem. Okay. Now in case of a figure 7, we just check that final answer. Sigma C, sigma B, tau T and tau TV. We go to the figure number 7 now. In case of a figure number 7, there is a 2 force applied. One is the P1, another one is the P2. So here I think the compressive, in this section there is a compressive load is applied, bending load is applied, some torsional shear stress is applied on this, as well as the transverse shear stresses. So you just check the final answer of this: compressive, bending, torsion and the transverse type of the shear stress. So that's the final answer of all the 7 questions actually. You just see all different type of the problem from any book and try to first find out what are the different type of the stresses is produced. Once you identify the type of stresses due to the load, then using the formula you can find out the stresses. Once you can find out the stresses, then using the concept of combinations of that loading or to find out the resultant of loading, that we have to learn it in this topic actually. You can club it to find out the resultant stress, to identify where the maximum stress is produced, where the minimum stress is produced, to design that component. That is the main basics of that song or solid mechanics, where we have to study the maximum stress is produced and we need to find out the factor of safety also. That we will learn it in the next part of the design. Okay. Now, today we just solve this numerical, where it is in one vertical short length pole where load applied 150 kilonewton, which is eccentric to that x-axis as well as the y-axis also. From y-axis it will be 100 mm, from x-axis it will be 50 mm. From y-axis it is called EY, from x-axis it is called the EX. So due to this load, what are the different type of stresses produced at A, B, C point somewhere here and the D point. This is the C point. This is the C point and the D point. On the top view of this diagram, you can see that cross section area is given. It's a rectangular where this is called the B dimensions and this one is called the D dimensions. And x-axis, y-axis, again that EX, EY is shown it in the top view also. This is the point where the load is applied. We need to find out what are the different type of the stresses produced. Now, can you please tell me which type of problem it is? We have seen the last 6 type of the problem. Which type of problem it is? Normal, shear, or normal shear? Okay. So if you check the P force, due to this P force, compressive stress is produced in all 4 point A, B, C, D. So compressive is the normal type, and also due to this P force, some moment is applied along x-axis and along y-axis also. Bending stresses is also produced in A, B, C, D. That's all. So only compressive and bending is applied at A, B, C, D. So it will be normal type of problem. Bending basically it will be tensile and compressive. In some point tensile, in some point it will be compressive. So if it is an plane, if I just want to bend it in this way, then the upper section is coming in tensions and the lower section coming in compressions. So it is basically the tensile or compressive nature only. Now we just first find out what are the different type of stresses produced in ABCD, and then we have to combine the stresses at the different point. To solve any problem, we first find out some dimensional parameter. So here, as 2 different moment is applied along x-axis and y-axis, we need to find out the moment of inertia about xx and yy. What is the formula of I for rectangular cross section? It will be the B into d cube by 12. The B basically, it will be that parallel to axis, and D is perpendicular to axis. So here, in case of a xx, if this is the xx axis, then parallel dimension is this, parallel to xx, and perpendicular to xx is this. So what is the B for Ixx? It will be 300. What is the D for Ixx? It will be 150 cube. So BD cube by 12 is 300 into 150 cube equal to 84.375 into 10 raised to 6 mm raised to 4. To find out Iyy. Now, axis is y and y. So again, as it is in rectangle, formula will be the same, BD cube by 12. But which one is the B now? Parallel to the y, that is in D, and perpendicular to y, that is in B. So we have written the formula in such a way that it's a dB cube by 12. So D is basically the 150 and 300 cube by 12. It will be 337.5 into 10 raised to 6. So remember, the formula of I is equal to BD cube by 12. And which one is a B? B is always parallel to the axis and D is always perpendicular to the axis. Now we also find out that another dimensional parameter, that is in cross section area, B into D, which is the 45 into 10 raised to 3. We just see what are that moment applied on this. So there is a 2 moment is applied along x-axis mx, along y-axis my. How to find out the mx? This force applied by distance from x means it will be ex. To find out my, it will be again this force multiplied by the distance from y is ey. So my is equal to p into ey and mx is equal to p into ex. Due to this, 3 type of loading is applied on this. Axial load P, moment along x mx, moment along y my. There's a 3 different type of the stresses produced. Due to P, compressive. Due to mx, bending stress along x-axis. Due to my, bending stress along y-axis. So you have to club all the 3 stresses in each and every point. Here we write down the resultant stress formula in each and every point. Compressive stress, it is always coming a negative value. Bending stresses along yy, bending stresses along xx. What is the formula of the compressive stresses? That is equal to the force divided by the cross section area. Bending stresses along yy is my, then iyy, and the distance from the y-axis. Distance from y-axis means the this distance. We are just talking about this distance. This is the distance along x-axis from y-axis, that's why it is coming the x. Similarly, in case of mx, sigma bx equal to mx divided by ixx, and the distance from x-axis, that is along y-axis, y. So we have written down the same formula here. Now we just check one by one. Now first we took that point A. What is the formula of point A? The generalized formula is written above. The same formula we have written here also. Sigma A at point A is a minus P by A. Compressive stresses is always applied in each and every point which is in the downward directions only. So this is the sigma C in each and every point. In each and every point. So just talking about A, B and C, D. These are the compressive stresses. It will be downward. That's why, and how to find out it? It will be P by A negative value. Now we know the My. My is equal to the P into Ey. So we have written down the formula of the P into Ey. P here, Ey is 100 mm. X is the distance from y-axis to point A along the x-axis. So that will be the B by 2. Similarly, in case of an mx, divided by I xx and distance from the x-axis to the point A. So d by 2 is basically distance from x-axis to A. So it will be d by 2. So this distance basically the d by 2 and this one is the d by 2 distance. Okay. So we are putting all this value here. Ixx, Iyy already written here. So after putting the value, we are getting P by A is equal to minus 3.33. Minus 3.33. Then this one is having 6.66. Again it will be negative. Okay, I just talked about the directions also. And this one is again coming the 6.66. So these are the three values. Now, can you please tell me what are the directions of the, we know that the P by A sigma C value is a downward. But what about the directions of the sigma by? The couple acting on this is in this nature, which will actually pushing that point A. If it isn't pushing the point A, I think there is some compressive type of the stresses is also applied here. So sigma B A Y along Y is coming the compressive type. So compressive type, that's why here it is written as a negative value. Now, due to this mx about xx, the moment applied here in this directions, which will actually lift the point A. So for this, it will be some tensile type of the stresses produced here. So sigma A x is tensile type of the stresses. So due to this tensile type of the stresses, it will be A only. So you just physically checked it. Due to the bending moment, the force is applied towards the point or pushing that force, or it will be pulling or lifting that point. According to that one, you have to write down the plus or minus. So finally, minus 3.33 Newton per mm square. So I have just converted to the 3.33 Newton per mm square. It will be in the compressive nature, as that answer is coming negative. Hence, it will be compressive nature downward axis. Similarly, you have to see that other point. B. Again, formula will be same. Only the directions to be understood here. For the B, what are the effect? I think the compressive is downward. Due to this my, it will be pulled off or lifted. So my is coming that tensile type of the nature. So you can see here that my is a tensile type of the nature, positive. Similarly, mx is also lifting the point B. Okay, so that is also the tensile type of the nature. So final answer is coming positive 9.99. So it will be 9.99 in tension type of the fluid. C point, everything is same, only the sign convention is different. So C point is coming somewhere here. This is the point C. So due to this my, again I think it will be lifting. So my it will be lifting, it will coming positive here. Due to this mx, it will be pushing down. Okay, due to this rotations, it will be pushing down. So that's why it is coming the negative. And compressive is all the time it will be negative value. Final result is again coming the negative one. So that's why it is in compressive nature towards the ground. Now the final point is the D point. Everything will be the same. Only the sign convention we need to check it. So I think for the compressive, it will be all the time downward. Compressive all the time downward. That's why it is coming the negative value here. Then due to the my, it will be again pushing forces towards the ground. That's why it is in compressive type of the problem. So it will be negative value here. And due to the mx is also applied on this direction, which will again push that point D towards the ground. So it is also coming the negative value. So all the three is compressive here. Hence, so final answer is the 16.65 compressive downward. So if you see all these three value, 3.33 compressive, 9.99 compressive, 3.33 compressive, 9.99 is a tensile, and 16.65 is the compressive. So out of this 4 stresses in 4 points, the heavily stressed point is the point D point. So the failure is occurred at the point D only. That's the thing, we have to learn it from this solid mechanics or strength of material. Actually, which point is the heavily loaded, and if that point is a safe, then the whole vertical post is also safe. It cannot be the break. I think you understood this point. In the next 2-3 part, I have to explain you the different type of the problem. I just gives you the glimpse of all the type of the problem. I had covered it in that next 2-3 part. This is that one problem of the beam. The second one is that one helicopter shaft where that some thrust load is applied and some torque is applied. So how to solve this, how to combine the stresses produced on that one. Or one problem, it's a very typical problem of that signboard, what you have learned it in the figure number 6, I think, on that slide. So that is the most typical, the different type of the stresses is applied on that one. So that also you have to learn it. I think with all this type of the problem, you can understand that whole concept of the combined loading and the stresses developed due to this. So just be with us, subscribe my channel. Whenever I upload the next video, you can notified immediately. Thank you very much.